Hi, everyone. Welcome to another episode of the Student Spotlight series, where we showcase some of the work our past students have done. Today, it is our pleasure to have with us Sruthi Nimmagadda. So, Shruti, can you tell us a bit about yourself, where you're from, what year of school you're in, and what course you've taken with CCIR?
I'm Sruthi Nimmagadda. I'm currently a junior in high school and I'm from California. I took the one-on-one research mentorship at CCIR.
So, how did you become interested in the program, and who was your mentor?
I learned about the program just by looking it up online, and I was really interested in the one-on-one research mentorship aspect of the program itself. I think the you like it's very unique. It offers a lot of benefits, like being able to talk to like a talented professional by themselves. My mentor was Dr. Giovanni Tritola. He works at Oxford, and yeah, it's very helpful.
So, what topic did you study with your mentor, or what was your research project?
My research project essentially analyzed the nozzle of a rocket, which is basically the end part where the fuel like combusts and propels the rocket forward. And my project used machine learning models to predict the amount of thrust the nozzle of a rocket generates.
So, how did you become interested in that topic? Was that something you had a prior interest in, or did you sort of, I guess, develop that research topic with your mentor?
I think before the entire CCIR project itself, I had an interest for aerospace engineering, but it was kind of like vague. Like I didn't know exactly what I wanted to do. But like when applying, I was kind of forced to narrow down my interests and like condense them down into like one idea that I really wanted to do. And I realized I want to talk about like rocket performance. And working with my mentor, we kind of like came to a consensus on what to research. He was really helpful. Like he told me which ideas wouldn't be effective in studying. Like there wouldn't be a lot of stuff to research in that. And basically, yeah, I just talked to him about it, and we came to a consensus.
So, what was the gap in the literature that I guess your topic was meant to address, or sort of where did you, how are you positioning yourself within the existing research?
So right now there's the most commonly used method of designing rockets and like testing and modeling rockets is a program called CFD, Computational Fluid Dynamics. And essentially it splits up the entire rocket into like tiny little parts and analyzes how the fluid or air affects each and every single part of it. As you can assume, that's like really resource intensive and time consuming, which means a lot of people don't have access to CFD, especially for people making smaller rockets. And that's why I wanted to use machine learning to kind of bridge that gap and offer a more cost-effective method of training rockets by using predictive models instead of like training every single rocket, like testing every single rocket.
I see. So, primarily then, what you were doing was developing this predictive model?
Yeah, we're using machine learning.
Okay, cool. Can you say a little bit more about the process there? I guess, how did you apply machine learning to do this? What were the sort of takeaways that you had in the end?
So my project, my entire research was split up into two kind of subsections. So my first section was about like generating the data using again like programming. I used a, um, a Python library called the NASA Rocket CE8 library, which my mentor introduced me to generate like the like certain parameters given certain other parameters. This can be anything from like the altitude that the rocket was at to the pressure inside the like the nozzle chamber. And essentially the first part of my project was just creating the data. During this stage of the project, my mentor also taught me about parts of the rocket. We went through like each of like we went through like the equation for thrust, and he kind of related that to real world things. And the second part of my project was more testing the model and picking the model with the least amount of error. I tested multiple models using the data I generated, and I found that one of the models worked the best. Essentially, the entirety of my project culminated in using machine learning to predict the parameters needed to generate a certain like user defined thrust, which I think would be very helpful for people who they know what thrust they want to reach, but they also have certain like limitations. So they can input those limitations and thus be able to like know what other like parameters that they need to decide.
So, if I'm understanding correctly, then so you created a data set during the first part of your research and
Yeah.
then use that data set to, actually, I think I'm missing something then. So you said you tested your model on the data set that you created in the first part of your project, right?
Yeah.
So what data did you use to train your model?
Um, I split up the data into an 80-20 split, which is typical in machine learning. And so trained the data I trained the model on 80% of the data, and I tested on 20% of it.
Okay, got it. Thank you. That's really helpful. So then I guess what were your results? You mentioned that one model fit best.
Yeah.
I guess, how well did it fit?
It was actually a really good error. It was very low error, but that was likely because the data was generated using using other programs. It wasn't like tested, which of course is something that like if I were to recreate this, I would probably like test out each of the data sets and create and generate the data set by myself. But using the NASA library, I think my error was around 0.9998, which is pretty good.
So have there been any previous attempts to use machine learning to, I guess, do a project like this, or would this be a first?
There have been previous attempts. But I just decided to do my own take on it and focus on one type of nozzle. And yeah.
Okay, so what kinds of, I guess, what differences maybe did you see between your work and once you finished and the existing research? So you
Um,
mentioned that you focus on a particular type of nozzle. Did you have any were there any differences in your results that were surprising or?
I think the largest difference between my research and then other people's research was that um, other people kind of like tested out their and they made their data set by testing out a rocket, and I didn't really have uh, I didn't like test out a rocket, so I think that was the biggest difference in the error of the models themselves.
Mhm. Did you end up finding that the same types of models worked best?
Actually, with my research, I tried multiple models and I found that one of these models that a lot of people say works really good called MLP. That model actually didn't work well in my data, which was really surprising to me. And a lot of the papers that have past research on this use that model. And MLP apparently it didn't work for me. I was talking with my mentor about it as well, and it didn't work because my data was like created, like it was more structured, and MLP is more effective in finding patterns between more unrelated data points.
I see. That's interesting. So then, yeah, so the fact that I guess if you had access to a rocket to generate your own sort of physical measurements, then maybe you would have gotten a more similar result. Is
Yeah,
it?
I see.
So, do you have any sort of big takeaways about the research experience? Do you feel like it's prepared you to do research in the future? Do you feel like it was a positive experience, or I guess did it subvert your expectations in any way?
I think I was really before this I had no experience with like any research in the first place. And I think that but working with my mentor helped me do my research in a more structured way rather than if I was doing it by myself. I like how we split up the project very clearly, and we always had like a timeline that we were like sticking to. Um, I think it was a very good first research experience because it kind of taught me the things I need to do if I do any research projects in the future and like the methodology I should keep in mind.
So, do you feel like this sort of bolstered your interest in aerospace engineering?
Yeah, like I was saying before this, I had close to no knowledge of what I want to do in aerospace engineering, but through this project, I was able to like understand my interest better, and I was able to like understand like different aspects of the field itself. And yeah.
So, if you were going to do, I guess, do another research project in this area in the future, do you have any thoughts on what you would be interested in doing? Would you want to extend what you've already done, or maybe go in a different direction?
I'd probably want to redo my project itself. If I had like unlimited funding, I would probably want to generate the data set myself, and I want to see like different relationships with the variables, like with chamber pressure and altitude. And I think that it would be a lot more interesting to see real world connections, um, yeah, real world relationships between these parameters.
Okay, cool. Yeah, I mean, that makes sense. I think that does seem like a logical next step. So have you finished your paper?
Yeah, I did. I submitted it to a conference already and it got accepted.
Okay, fantastic. That's great news. So if you were to give someone who is going to do a similar type of, research mentorship program advice, what would that advice be?
I think if I was to give somebody advice about this project, any type of project, I tell them to probably, um, I tell them to listen a lot during the like learning about all the components of a rocket phase. I think that knowledge was definitely something that I didn't have before, and that was a very pivotal part of my research itself. But I'd also tell them to, try to experiment as much as they can. I think that the research I did, I should have gone more in depth. Like one of the findings or one of the next steps I included in my research paper was to include different factors like toxicity and fuel cost to the project itself to make it more real world applicable.
So, and also sort of more generally, I mean, I guess with learning to do research, is there anything that you feel like maybe surprised you about that process or was easier or harder than you expected?
I think it was always just like the entire process of writing a research paper seemed so daunting to me because I just never knew how to start it, and then it seemed like a lot of work, and it seemed like you need to be like a person with like a PhD already. But I think that writing a research paper is definitely like it's possible. And yeah, I was very intrigued by writing it itself.
Yeah, I think that's good advice. I mean, I think people definitely shouldn't be too intimidated by research. I think ideally research should be a kind of like formalization of the kind of learning and thinking everyone already does every day. Like it's not some radically different thing. So, yeah, I think that that's a good takeaway. Do you have any other final thoughts you'd like to share about your experience?
Um, Well, I just want to say that it was a very rewarding experience. I feel like I was learning something in every single session, and I felt like I was closer to like achieving my dream. I was just yeah.
Yeah, that's great. Well, in that case, thank you so much for sharing, I guess, sharing about your project. And good luck. I mean, I'm sure that you'll have many more opportunities to do this kind of research in the future.
Thank you for having me.